Hello wonderful person, this is Anton, and in this video we're going to be talking about comets. But actually, not just comets, all of the comets from our solar system combined into one. Let's find out what happens, and welcome to What the Math. So this right here is actually one of the most famous comets out there, the Halley's Comet. This particular object, if you were to take a look at it and compare it to our planet Earth, is not very big. It's actually relatively small. But nevertheless, its size, if I were to actually select it here, is about 5.5 kilometers in radius. So it's definitely large enough to destroy civilizations on the planet, but not large enough to destroy the whole planet. But what if we were to combine all of the comets from the solar system into one? How big of a comet would you actually get? Now, to explain this or to answer this question, I actually have to first talk about where comets come from. And to do this, we're going to zoom out of here. As a matter of fact, we have to zoom out quite a lot to a region of space known as the Oort cloud. This is a region of space named after a Danish astronomer, Jan Oort, who, along with another astronomer, actually predicted it many years ago. So right here, we are at a distance of approximately 1,000 astronomical units. This is 1,000 times the distance of Earth from the Sun. And so here, this is sort of where you expect the comets to reside. But this region is actually very large. You actually have to zoom out quite a lot before you reach the end of Oort's cloud. A more visual representation of this is actually right here, and you can see that this is kind of where we were, 1000 AU, and this is kind of where it ends, over 100,000 or possibly even 500,000 AU, which is just over 3 light years away from our Sun. As a matter of fact, Oort's cloud is actually beyond where Voyager 1 spacecraft is right now, the farthest craft from our planet. And it's basically a region of space that we have never visited, never really seen any objects from except for the ones that come to the inner solar system. So it's a very hypothetical region, but we're almost certain that it exists, and we're almost certain that it has a lot of comets out there. We usually see the effects or the results of these comets on planets. Like, for example, this is the Shoemaker-Levy comet that actually crashed into Jupiter many years ago. And we even got to record this event. But what's interesting about the Oort cloud in general is that it actually has a tremendous amount of these comets just kind of waiting for them to be disturbed by something so they can actually come closer to our planet Earth or to the inner solar system. So we are almost certain that a vast majority of these comets are actually the leftovers from early solar system development, and were most likely kicked out of the inner solar system by these guys, by larger objects like Jupiter, Saturn, that as they were basically being created, threw away a lot of material into the outer solar system, into the Oort cloud. And so a lot of these comets most likely are made up of various ices. So basically things like methane, water, ethane, carbon monoxide, and even various hydrogen cyanide components. So this is another famous comet, Swift-Tuttle. And these comets are essentially, at least for the most part, relatively large. So we expect at least 1 trillion of these comets to be more than a kilometer in size. And quite a few of them, possibly 1 billion of them, to be large enough to cause major destruction. Now, what if we were to actually measure the entire mass of the entire Oort cloud and then try to add it into one massive object? So first of all, there's actually two parts of Oort cloud. One of them is a kind of a disk that's known as the inner Oort cloud, and that one is relatively small. But then there's this really massive sphere around our Sun, basically this very large, but I guess somewhat invisible spherical volume around our Sun and around our solar system that's known as the Oort cloud, main Oort cloud. And that particular region is definitely going to be massive if you were to actually combine everything from it into one object. So let's try this. Let's do a little bit of simple math here and imagine what this object would look like if it was right next to our planet Earth right here. So first of all, we're going to use Halley's Comet as a kind of a prototype. So let's go back to Halley's Comet, which is right here, and let's place it around our planet Earth. So here's Halley's Comet. It's about just over 5 kilometers in radius. And what we're going to do is basically use the scientific assumption that there's about 1 trillion of such objects out there. Possibly a little bit less, but let's just say that it's 1 trillion. So what we're going to do is we're going to multiply the mass here by 1 trillion. Trillion has 12 zeros, so we're going to add 12 right here and see how big of an object we get. So first of all, maybe we want to actually move Halley's Comet a little bit farther away from Earth, just because we want to actually create an object that we can compare to Earth. And we're going to keep everything here as it is right now. So the density and the radius and the mass is going to be the same until we actually change this part. So it's going to have 26 zeros after 4. And as soon as I press enter, here is the object that you get. Look at that. That is the sort of the upper limit of all of the comets as one. And it's still named Halley. Now, as you can see, it's basically a large water bowl because for the most part, it's just ices that have now melted. But if I actually just let it run for a few seconds here, for a few minutes, Earth will most likely start falling into it. Its current mass, and this is once again an upper mass of this object, is about 70 masses of Earth. Now, this is actually what we used to think. Some scientists actually even thought that it was about 300 masses of Earth. Some even thought it was about 2% of the entire solar system, which is about 600 masses of Earth. But a more recent analysis actually lowered this to about 5 masses of Earth. So we don't really exactly know how much of mass there is out there, but we think that it's definitely at least 5. So this is the lower limit of all of the comets together. And so this is how much of stuff there is out there in Oort's cloud in these little pieces of about 5 to 6 kilometers in radius that we call comets. But there is like 1 trillion of them out there. There's a lot of them, and they always have a high chance of coming into our inner solar system because gravitationally they're actually not that strongly attached to our sun. So a passing object like a star nearby or even a rogue planet can actually dislodge them and have them then fall into our inner solar system and possibly collide with planets like Earth. Now, we're going to basically just let this run for a little bit and see what happens. But as you can see, there is definitely a lot of mass out there. So Oort's cloud is surprisingly, oh wow, that's a crazy explosion. Oort's cloud is surprisingly very, very massive. It's anywhere from 5 to maybe several hundred masses of Earth in mass and contains a lot of really cool material that used to be in the inner solar system, but then basically got thrown out by Jupiter, by Saturn, by a lot of other planets, including Earth, as these planets were forming. So in other words, if you were to combine the entire Oort cloud into one single object, you would get a pretty large planet. You would get a planet that's at least 5 masses of Earth, up to maybe even 300 masses of Earth, which is basically the mass of Jupiter. All in all though, it's definitely a really interesting hypothetical scenario to explore, and hopefully one day we'll actually be able to travel faster than we travel right now, so we can actually go and visit some of those objects and maybe even analyze them and study them in a little bit more detail. Because as of now, even objects like Voyager right here will actually take hundreds of years to even reach Oort's cloud. It's going to be a very long time before we can even potentially approach an object with a craft that we have right now. And by then, this little guy is going to run out of power. So we don't really have any means of studying these objects. Because the only way we actually get to study these objects is when they approach the inner solar system, because they were dislodged by something out there in the Oort's cloud. But remember, it's so far away that it would take them thousands of years to even get close to our planet Earth. So it's not a very effective way of studying these unusual objects. And because these objects are basically just leftovers from the creation of the solar system, at least one of them might actually answer quite a lot of questions about not only the origin of our solar system and our planet Earth, but also origin of life. Maybe deep inside these objects there's actually the answer to the question of where life on Earth came from. But until we actually get to study these, we won't really know. Anyway, that's all I wanted to show you in this video, and hopefully now you know a little bit more about comets, the Oort cloud, and the entire mass of the Oort cloud combined into one single object. And if you've enjoyed this video, don't forget to subscribe, share this video with someone who enjoys watching space videos, and click that bell button to be notified about videos in the future. I'll see you guys tomorrow. Come back tomorrow to learn something else about space you may have not known, and space out, and as always, bye bye. And before we finish, let's see what this would look like as an object 300 masses of Earth as a single bowl of water. So that means I have to change this from about 26 to about 27. And okay, this humongous bowl known as Halley is now 2.2 masses of Jupiter. That is a tremendously large object. As a matter of fact, I think Earth could easily orbit around it. Look at that, this is beautiful. And I think this spot right there, that's actually from previous Earth colliding with it. I don't know why it's spinning so fast though, that's kind of interesting.